Yes, thank you. Yeah, so let's talk about the technicalities, and this will answer one of the questions, at least in the chat. So how do we store networks? How do we represent our objects as networks? And first, how do we store networks in machine-readable form? So all these things I showed you were pictures, basically, right? So basically, in the end, they were all PNGs with visualizations. And this is not something that computers, are good at extracting data from. I mean, they could now with LLMs and stuff, but still, that's not machine readable per se. And a very common and very popular and very simple option to do that actually in a proper machine readable format would be a CSV table. I mean, you could use any table, but in the end, most programs which work with networks import CSV and work with CSV, so it's better to store it as CSV table. And for those of you who don't know, CSV table is basically just a file in your notepad where you basically model a table by by representing each row as a line and each column or each border between columns as a comma or other form of separator. People use semicolons, people use tabs, but comma is the most common and gives the name to the format CSV, which just means comma separated values. And you can like this is the simplest form of CSV table encoding network edges that you can imagine here on the left of this slide, and on the right you can see a network which I created from that CSV basically. And of course you can add more information. For instance, we spoke about weighted networks already. This is something I wanted to introduce at this point in the presentation. So basically, if we not only record that Daniil knows Joanna and Joanna knows Marco and Daniil knows Marco, but if you also want to record the fact that, for instance, Joanna met Daniil 3 times, but Marco met Joanna 15 times, and Marco and Daniil met 2 times, and use this as a some kind of a proxy for intensity of interaction, let's say. So we can add this also as a separate column. So you can see in this case I'm adding comma on each line, which means I'm adding a separate column on each lines. And from this network you can come up with, from this formulation you can produce this kind of network on the right. So yeah, we just introduced the concept of a weighted graph, which is quite important. So this is a very basic format of storing network data. There's a couple of other widespread formats. So one of them is GraphML. It's XML-based format for network storage. So if you look at this XML carefully, you will see there are certain elements which store nodes, like node with the ID n0, node with ID n1, and there's the edge, which as XML attribute stores the information about which node is connected to which, and of course there could be an attribute for weight and so on. And there is another also XML-based format which is very popular now, which is called GXF, Graph Exchange XML format. This one is more complex and also more feature-rich, so you can encode things in there which cannot be encoded in a simple CSV table. Like even you can encode the visualization parameters already embedded in the graph. So this is something that you might come across later, but for now I would say CSV table with network edges is the simplest format. And here is, for instance, the CSV format which is actually accepted by Gephi. The only alteration which I did to the previous example is I added this header line basically, which is the names of the columns essentially, which should be like this if you want to work with this CSV in Gephi. So it's source, target, and weight. But we will use a certain tool which adds this for you automatically, so no worries. You will not have to remember and write them by hand, because this is the place where it's really easy to break things. If you just add an additional space before source, or you write target with a small t, then Gephi will not accept this as the proper CSV for a network, and your network will not work. So the next question, and I think this will answer some of your questions in the chat. How do I actually obtain or produce such data? And the answer is multifold, let's say. So one way is to find the ready-made data. Like when I showed you this Karate Club data, I didn't construct it myself from the paper by reading the Wayne Zachary's paper. I just took it from the website of Gephi, which contains this data. So it's if you go to this dataset storage by Gephi, you will find this karate club in multiple formats, including maybe even CSV. Or there are other large repositories like this networks.qt.de. It's a large repository of very different networks, from friendships of dolphins recorded by marine biologists to Bitcoin transactions, or like Twitter friendships or scientific co-authorship, you name it. And of course there's Dracor. Again, like I'm a representative of Dracor, so I have the right to promote it shamelessly. And Dracor currently contains more than 4,000 networks of theater plays in 17 languages, as far as I counted. There's 21 corpus on Dracor, including, lots of major European literatures like French, German, Polish, English, Italian, and so on, coming all the way up to Ukrainian and Russian and Hebrew. Yeah, and of course, this is something that's this only works if you're content with working with somebody else's data, right? But what if you want to model your data as network on your own? Well, first of all, let's get a bit, on a more abstract level and ask ourselves, like, what do you actually want to operationalize? Because if you remember, when I was answering your question, sometimes I was saying, okay, what do you want to model? And what is the point that you want to model? What should be the connection in your network? Because like sometimes it's very formal, right? I mean, we can get like sometimes it's already machine readable. Like my connections on Facebook are already like something formal. They either exist or not. But it gets harder if you try to model objects in the humanities, right? If we have a novel and characters somehow interact there, like what do we count as interaction is already a tricky question. So we have to formalize it. You have to formalize it. What's a node? What's an edge? And then you have to encode it. Then you have to encode it in machine readable form. So basically produce in the minimal version, produce this kind of CSV which I showed you. And of course there are several ways to do that. So of course there are ways to automate this. Like, I mean, we wouldn't have more than 4,000 plays if we did it manually, of course. There are different ways to automate it. Like you can look at the play, for instance, and already figure out how to, like, what would be the way to automate this stuff. Like it's pretty easy now to extract all the mentions of characters from a literary text, right? There are tools for that, named entity recognition, LLMs can do that as well. There are also ways to extract certain, formal connections between characters. Like the most stupid and formal you can imagine is, two names mentioned within a certain space of text, like within a paragraph. And that already, if you do that to a big novel, that will already give you a network which will be rather meaningful, even though you will capture some false connections, like when some character is just mentioned in the passing and he's not present in the scene. So it's only just this co-occurrence, but not really co-appearance network. And yet, if you do that to a big novel, just because the most of the connections will be mostly meaningful. It will be real co-appearance, real communication between characters. So you can already go a long way, by doing it this way. And this, of course, the profit is that you can automate this. The profit is you can just extract all mentions of characters, somehow identify them between each other, and then just connect everybody who is mentioned together and count the frequency of co-mentions. And then you will have your network, basically. So if you're interested in approaches to this problem, specifically in fictional character networks, I really highly recommend this paper by these two French people whose names I will probably not be able to pronounce anyway, which is called Extraction and Analysis of Fictional Character Networks. I really like this paper. It's a big survey which basically outlines the problem in a very good way. Especially this figure 1 is very good. I think it just outlines the whole process. But we are not going to do that because that's a separate big problem. How do you do that? And that's a separate engineering challenge. Let's say, how do you automate extraction of network from your particular data? So I will skip that complexity, and I will instead show you a simpler approach, which is very useful, especially somebody asked for didactic purposes, which is especially useful for didactic purposes. This actually is a tool which was built for didactic purposes. So this is something that I will show now. This is a tool called EasyLinaviz, and maybe I will do now this. I will turn off the sharing for a short time, then I will turn on the sharing again. And I hope you now see my screen again. What I will do now is I will basically show it to you, and then I will send also, I will, sorry, I will share with you the slides now. So these are the slides, and I will also share with you the manual to this tool, because we will now practice with it. Yeah. So, and like, now you can either like follow me still, because I will show you a couple of things before you play around, or just look at the manual and play around for yourself, whichever suits you best. So this is the tool, and it looks pretty like, when you just open it, it doesn't look very understandable, right? You just see some three random windows. But actually, if you look here, you have examples. And if you open examples, you will immediately figure out what's going on. So for instance, let's take The Frogs by Aristophanes. And this whole thing doesn't matter. It's basically a text for human. So let's just scroll down a bit until the first hashtag, until the first hash sign. Hash sign is really like the core part of the syntax that you have here. So we'll only be working with this particular part of the EasyLinaviz, and the only kind of part of syntax that you need to know here is this hashtag. So what we do here basically is, or what the person who was encoding this, in this case Professor Frank Fischer, was doing here, is he was reading the play by Aristophanes. And what he did is basically he was putting hashtag each time he encountered a new division of a play. So basically act, scene, and then within a scene, he was recording who is talking. So he was recording here, Xanthias is talking to Dionysus. And so he put Xanthias as on one line, and he put Dionysus on another line. And immediately as he did it, and we can probably show it if I remove all the rest, immediately when he did it, he already got a network. So he already got a network, and specifically a network in machine-readable CSV form. You see here we have the same CSV, which is automatically generated for you. And if there was somebody else, for instance me, in that scene, in the frogs, he could add me as well, and I will be also there in the network connected to both Xanthias and Dionysus. And suppose there was another, second scene. So let's call it second scene. And in the second scene, Daniil was talking to Marco and John. And so now we encoded this interaction as well. And suppose there was a third scene, and there was Joanna again interacting with Marco, but without Daniil. And now what we have here is a network which reflects this kind of interaction. So everybody who is here were connected, everybody who is here were connected, and everybody who is here were connected. But since there was already a link between Joanna and Marco, what happened? Could you tell me what happened actually? Just to check if you're still with me. What happened when I added the Joanna-Marco connection for the second time? What changed? Yeah, it added weight. Yeah, the line got thicker, that's true, but the representation was just a reflection of this formal encoding here in the CSV file, which you can download, by the way, all the time and use in other network analysis tools. Yeah, so instead of 1, which everybody else has as a weight, they got 2 as a weight. So you can see how it works. And basically, this whole stuff can be removed. So the only thing that's important is hashtags and the fact that after a hashtag, you have at least one symbol. So if you have here, I don't know, A, that's okay. I mean, they don't have to be meaningful, to be honest. Like they could be meaningful, but uh, because it will be easier for you to read. But you can just call them with one letter, or even just put 1 everywhere. It will not break. What will break, though, what will break is if you just remove it completely. So this doesn't work. You see, I have a hashtag, but I don't have any single symbol after it. If I add at least a space, that's already something that works. And of course, so that Joanna was always, so that the character was identified with himself, he has to be named absolutely identical. Uh, before in the first version of the tool, even the space after the name was already enough to break it. Now I think we added trimming for the spaces. But if you forget, for instance, if you write Joanna with one N, of course the tool will think it's another node. So you will have Joanna and Joanna. So I mean, there is no other way but to always write them identically. And again, this is not a tool which will automatically extract things for you. Okay, get me right, please. So this is not some NLP processing machinery which will get you a network out of thin air or out of your novel automatically. This is just a tool to encode networks with your own hands. But it's a pretty neat tool. It's a pretty useful tool, especially if your network has a continuous nature, let's say, if it's generated by characters or actors of people continuously speaking to each other. And if you click download CSV, what you will get is basically a file which already is formatted, so that you can upload it to Gephi or to any other network analysis tool. So I hope this answers the question of like how do I actually make a network, right? And what I suggest now is that basically let's play around with this tool. So I will turn off my screen to not distract you. What happens if you had scene 4 with a totally new person? This person will get added to the play, actually, as a node which is not connected to anybody. If you just add him alone and nobody else, alone, this will be an isolated node. The network does not have to be automatically interconnected. There are networks which have like separate, totally independent components. And in this case, you will have this kind of bastard component, basically, which will just contain one character without any edges. That's normal. That's okay. I mean, it will get tricky once you start counting centralities, but that's maybe a topic a bit too advanced already. So what I suggest is just like open the manual, and I'm sending it again. I hope it opens for you. And then try encoding place, try downloading a CSV, or try encoding anything you want, basically. It could be a text, it could be something that you have in your life. I don't know, like how often I met whom last week, let's say. You can try to. Yes, there was a very good question in the chat as well about directed networks, which is something I didn't introduce consciously. I have it in my later slides, but we'll probably not get there. So yeah, one thing aside from weight, one other very important addition which can sometimes be added to networks is the direction of an edge. So if you're modeling, for instance, interaction, let's say trade, and or even dialogue, and there is a similarity in that, like there is asymmetry in that. So like one country sells 100 million to another but only receives 10 million back. So it can't be modeled as a weight for this edge, right, between these countries, unless you introduce two different edges, one of them direction AB and one of them direction BA. So that's called directed graph. And that's something you can't do with isLiniviz. So the tool wasn't made for this. The tool is perfect. The tool is consciously made very simple, so it doesn't have that feature. You can still do that. You can still model that in CSV, though. You'll just have to modify that CSV. Basically, you could use Excel for that, and then just you can have like, because as you might have noticed, the CSV has this header, source, and target. So they're not accidentally called source and target. That's where you know that it could technically be also encoding a directed network. So you could put like source Daniil and target Joanna, and will be mean communication from Daniil to Joanna, and then Joanna to Daniil could be a different edge basically, and they could have separate weights. But that's not something you can do with isLinux.